Hello everyone. Today we are going to find the fixed end moments in this fixed beam using column analogy method. In this beam we have uniformly distributed load for the full span. Now in this beam let us find the degree of static indeterminacy. In this beam the number of unknown reactions and moments are 4. They are the moments MA and MB and the reactions RA and RB. The available equilibrium equations are 2. The degree of static indeterminacy is equal to 4 minus 2. We will get 2. From these 4, we have to remove any 2. Let us remove MA and MB. When we remove MA and MB, this beam will become a simply supported beam. You can see that I have converted the fixed beam into a simply supported beam. Now we have to draw the bending moment diagram for this beam. We know that in the simply supported beam, in both of the ends, the bending moment will be 0. If in the simply supported beam, uniformly distributed load is acting for the full span, the maximum bending moment occurs in the center and the formula is WL square upon 8, and the bending moment diagram will be in the parabolic shape. Now let us convert the bending moment diagram into a conjugate beam. We have to divide the bending moment by EI. This diagram is called MS diagram. Now let us make the analogous column. Analogous column is a short column having the cross section 1 upon EI cross L. P is the resultant load in the analogous column due to the conjugate beam. The formula to find the stress at the base of the analogous column is P upon A plus or minus PE XA upon IY. To find the stress in the point A, that is MIA, we have to only use the positive sign in the formula. To find the stress in the point B, that is MIB, we have to only use the negative sign in the formula. E is the eccentricity. We know that this diagram is symmetrical, so the resultant P occurs in the center. In this case, the eccentricity E will be 0. Since E is 0, these two terms are eliminated. Finally, for MIA and MIB, we will get P upon A. So, for MIA and MIB, we will get the same value. Now, let us find the resultant P. For that, we have to find the area of the conjugate beam. For this parabola, the area formula is 2 by 3 BH. Here the breadth is L and the height is WL square upon 8. We know that finally EI will be eliminated, so no need to consider EI. L into L square we will get L cube. We can eliminate 2, here it will be 4. 4 into 3 we will get 12. Now let us find the area of the cross section of the analogous column. The area of the cross section is 1 into L. So for the area we will get L. We know that MIA and MIB will be same, that is P upon A. We have found P and A. Let us apply both of them. We can take this L inversely and then multiply. We can eliminate L and here it will be L square. Finally, for MIA and MIB, we are getting WL square upon 12. Now, let us find the stresses MSA and MSB. For that, we have to look at the MS diagram. In the point A, the stress is 0. In the point B also, it is 0. So, MSA and MSB are 0. We have found MIA, MIB, MSA and MSB. Now let us find the fixed end moment MA. The formula is MSA minus MIA. Let us apply both of them. Finally for MA we are getting minus WL square upon 12. Now let us find MB. The formula is MSB minus MIB. Let us apply both of them. Finally for MB, we will get minus WL square upon 12. For MA and MB, we have got negative moments. That means both of them are hogging. MA will be acting in the anti-clockwise direction and MB will be acting in the clockwise direction. Alternatively, we can find MA and MB by removing MB and RB. You can see that from the point B, I have removed the moment MB and the reaction RB. So the point B becomes a free end. This beam was a fixed beam, but now it has become a cantilever beam. Now we have to draw the bending moment diagram for this beam. We know that in the point B, the moment is 0. To find the moment in the point A, we have to use left-hand side rule. Clockwise will be negative and anti-clockwise will be positive. The UDL is acting in the clockwise direction so that it will be negative. For the UDL, we have to multiply with the distance and distance by 2. So we will get WL square upon 2. We know that the moment is negative, so we have to draw the diagram below the line. Since there is uniformly distributed load for the full span, the diagram will be in the parabolic shape. Now let us find the centroid distances. This is a second degree parabola. For this parabola, the centroid distance towards the left is 1 by 4 into b. Here the breadth is L, so it will be L upon 4. The centroid distance towards the right is 3 by 4 into b. The breadth is L, so 3L upon 4. In this analysis, we only need the centroidal distance towards the point A. So only we need this centroidal distance. We will not use this distance. Now let us make the conjugate beam. We know that it is a negative bending moment diagram so that the pressure will be acting upwards. Now let us make the analogous column. In the analogous column, the resultant P occurs at the distance of L upon 4 from the point A. In the analogous column, we know the formula to find the stress at the base. We have already seen this formula. Now let us find the resultant P. For that, we have to find the area of this diagram. This is an second degree parabola. For this parabola, the area formula is 1 by 3 BH. Here the breadth is L and height is WL square upon 2. We know that it is a negative bending moment diagram, so we have to apply a negative sign. L square into L, we will get L cube. 3 into 2, we will get 6. So for P, we have got minus WL cube upon 6. Now let us find the area of the cross section of the analogous column. The area is 1 into L, so we will get L. Now let us find the moment of inertia Iy. We know that the cross section is a rectangle. We know the formula to find the moment of inertia in the rectangle. BD cube upon 12. Here B is 1 and D is L. Using the formula, we will get L cube upon 12. Now let us find the eccentricity E. We know that in this analogous column, the center lies at the distance of L by 2 from the point A. This is the eccentricity E. We know this distance L by 4. So to find the eccentricity, we have to subtract L by 4 by L by 2. L by 2 minus L by 4 is L by 4. So for the eccentricity, we have got L by 4. Now let us find XA. XA is the distance from the center to the point A. We know that this distance is L by 2. In this formula, we have found everything. Let us apply them. Positive into negative, it will become negative. Negative into negative, it will become positive. We can take this L inversely and then multiply. Also, we can take L cube upon 12 inversely and then multiply. We can eliminate this L. Here we will have L square. We can eliminate L cube. We can eliminate 6 and 2 and 12. L into L, we will get L square. Finally, we will get this. To find MIA, in this equation, we have to only use the negative sign. When we add these two, we will get minus 5WL square upon 12. To get MIB, we have to only use the positive sign. When we add these two, we will get WL square upon 12. We have found the stresses MIA and MIB. Now let us find the stresses MSA and MSB. For that, we have to look at the MS diagram. Let us find MSA. In the point A, the stress is WL square upon 2. We know that it is negative. Let us find MSB. In the point B, the stress is 0. So MSB is 0. We know the formula to find MA, that is MSA minus MIA. We have found MSA and MIA. Let us apply both of them. Negative into negative, it will become positive. Minus 1 by 2 plus 5 upon 12. We will get minus 1 upon 12. So for MA, we will get minus WL square upon 12. Now let us find MB. The formula is MSB minus MIB. We have found MIB and MSB. Let us apply both of them. Finally for MB, we will get minus WL square upon 12. In this analysis, we have found MA and MB. Now we are going to end this session. Thank you for watching this video.